Hello and welcome to TidyX episode 22. It's a really high energy episode this week. You'll see what I'm meaning in a second there. All right, so TidyX is a screencast where we go through and try to explain how our code works. My name is Ellis Hughes. I'm a statistical programmer. You can find me on Twitter at Ellis_Hughes.
And I'm Patrick Ward, and I do data analysis in sport. And you can find me on Twitter at OSPPatrick. You can reach the both of us either through Gmail at tidy.explained@gmail or on our shared Twitter page, tidy_explained at tidy_explained.
All right, cool. So the data set this week is on European energy. That's why it's high energy. Yeah. All right, so this is from Eurostat. They went through and pulled some historical energy production. They showed a pretty cool visualization here on the main README from Thomas, showing the different energy production of different countries. Just looking at green energy, conventional thermal energy. Lots of fun data here. There were actually some confusion this week because there was a variable that was a little bit confusing to a lot of people. So that was kind of fun because that's real life. Not every time does data come in nice, clean, square, and you're able to just jump into it. I mean, we try to do this with Tidy Tuesday. I know Thomas does, but that's not always the case. So it was a good learning lesson for a lot of people.
Rarely is it the case.
But there was some really fun visualizations. A lot of people reproduced this. I know I did because it took my own spin on it. But the one that we picked this week we thought showed a really good example of a new plot that we actually haven't discussed yet.
Yeah.
So this is from Kelly Cotton. Thank you, Kelly, for letting us go through and explain it. So this is her plot. Patrick, why did we pick this one?
Yeah, it's a dumbbell plot. So we haven't discussed these before, but I actually quite like these, and they're interesting in two different situations I can think of immediately off the top of my head, and those will be the two situations we go through here today. One is if you're attempting to compare the same variable over time, and you sort of want to look at how it's changed over that time. Basically, not like a time series, but between 2 points, almost like if you were in stats to do like a t-test between two different time points. The other situation is if you're trying to compare the difference between two variables that are potentially on the same scale, and they might be explaining let's say a specific overarching quality of someone or something, and we'll get into what that is with our ball hog analysis.
Yeah. All right. So Kelly shared her visualization here, and she also has got a link to her code here. So this is her GitHub page that she's got at Kelly Cotton Tidy Tuesdays. So we ripped that down, put it in our studio session, which we've got going on here. So we'll just jump into starting to explain it. All right, so she's using it in R script as opposed to R Markdown, which is perfectly fine. She's got her very well-structured libraries that she's loading at the very top here. She's got Tidyverse, like everyone does, Tidy Tuesday R, woo. Then she's got ggalt, which is the library that'll help her create those dumbbell plots, library scales, which makes everything look prettier, and then patchwork, which is then used to deal with grobs and the plots and putting them all together. Next, she does a thing that we also like to do, which is setting her theme. She uses the theme light here, and she uses theme set, so now all our plots will be using that theme. She uses Tidy Tuesday R to load week 22 or 32. Wow! So let me before I get too far, let me run all that. So we download everything, and then she pulls out energy types out of the data object from Tidy Tuesday R and assigns it to energy types. She's got that there, and then it looks like she actually downloads country totals as well. So she could have done country totals. I can type, I swear. Tuesdata country totals. She could have done that, but she also used the slug. So it was both ways you could have pulled in the data here this week. So let's run that. So now she's got the two data sets that are available from this week's Tidy Tuesday data repo this week. And so she's got here, she annotates it. She's a plot she abandoned, which is totally common. I do this all the time. I write code and I'm like, I decide I don't need it anymore, but I don't want to get rid of it. I've put so much effort into it so far. I don't want to delete it, so I just comment it out.
You never know when there's something to learn from it too. Like
Yeah,
I've done that before where I've deleted it and been like, oh crap, I wish I had those 4 lines that I wrote 2 hours ago.
yeah.
Sometimes
So
yeah.
I know that feel. All right. So then what she does is she goes through and uses the country totals data set there. She subsets to keep only total net production. So country totals here is 185 rows, 7 columns here, and it shows the amount of energy that they produce. I'm assuming it's got the imports and exports. Okay, so yeah, anyway, so total net production. So the amount they use is essentially what this is from what I can net production. No, what they produce. I can be smart. And then she goes through, so she subset that, so she only keeps the rows where it's total net production. Orders by 2018, which is the amount that they produced, total net production, in 2018, and removes or keeps the top 5.
Yes.
So that's what that's doing there. So slice max that. So she ends up with a tibble that's kept the top 5 based on their 2018 production. She then goes through and converts her energy types, type out of the energy types data set into a factor. So this is really important and very useful to do if you're dealing with categorical variables like we are here. And she can then also define the order in which they'll show up in your plots. So this is critical for what's going on next. So she's ordering it by thermal, conventional thermal, nuclear, hydro, wind, solar, and geothermal, and then other. So she's now turned the type field into a factor. And then it looks like here, places where the country is an A, she replaces the United Kingdom. I'm guessing that's there was some sort of bug in the data where it was supposed to be UK and it wasn't. So she does that conversion there. So any cases where it's NA, replace it with the United Kingdom, and then she assigns it back to that same field. So now we've got a clean energy types data set there. And then she goes through and creates the theme. So Patrick, do you maybe want to take us through this quickly?
Yeah, this is just a simple way. Usually, if you've seen our previous screencasts, we define our theme within our ggplot call. She's just going to define it ahead of time, which is totally fine. So she creates this preset dumbbell _ theme. And so she uses theme function, which you would use with ggplot, and she's basically telling it where she wants the title to land up. That's the HJust. So it'll land it right in the center of the page, and the face bold. And then she's setting the backgrounds for the plot and the panel to a hex code that she liked. I don't know exactly what F7 is going to produce, but something that she liked. And then she's blanking out the minor, major grid axes. You could have done this. She set the theme to be theme _ light. You could have actually done this if you set your theme to classic. It'll automatically get rid of the minor and major things, so you can save some typing, minor and major lines, grid lines, so you can save some typing later on. And then she also removes her axis tick marks and her panel border. So it's going to be a pretty blank plot with some very specified coloring behind it that she likes for the rectangle that the plot is going to sit atop of. And then she comes down here and she's going to use that energy types data set, and she's going to subset out country in the top country. So that was actually that data frame that she created first, where she sliced the max, the top 5 from 2018. And if you look at how she subsetted this down in the ggplot, she actually does top countries, $country. You could have saved one step. She could have added right at the end of that, another pipe, and just said pull, or I think it's
yeah, it's pull.
Yeah.
I'm just countries.
Yeah, and if you do that, it's going to spit out a vector of the countries that she's actually calling.
It helps if I spell it correctly.
I think it's country, isn't it? Yeah.
country.
Country.
I it helps if you reference the correct.
Yeah. And so there you go. So then she could have just done subset, or filter would have been another option. Filter is the tidy version of subset, but she could have done country in country, and that would have worked just the same. Both work the same.
It'd be top.
Oh, top country. Yeah. So it would have worked the same way. And then she's got a few other. There was 2 levels in this week's data set, so she's subsetting out level 1, and then she's doing a few not is type of filters here. So not conventional thermal and not other as the type. And so after that subsetting, she's ready to make her plot. So using ggplot for the dumbbell plot, you need to pass 2 x values. So an x to start and an x to end. So x and xn. So she's making a comparison here between 2016 and 2018. So it's going to draw a nice little line between those 2 values. And then her y value is country name, and she's grouping by country name. Geom dumbbell, she's going to say that she's got some hex colors there. So her color for X is going to be a certain value. And then she sets a color for X end down at their bottom. So that's how you're going to be able to differentiate the 2 variables. She has some stuff that's little styling points there, like size for the X, the size, and size for X end, and those kinds of things. Scale X continuous. This is using the scales package for the labels there. She's giving it a comma. So if it's in the thousands or the millions, you get a comma in the value. And then she's doing a bit of facet wrapping here to wrap it by type. And so that's going to be by the type of energy type that's going to come out in the facets. And she wants that in one single column, because I'm guessing, if we remember the plot, she's going to patchwork this single column faceted graphic to another one on the right-handed side. Her labels are blank. She gets rid of those. And then the theme strip background is she wants a specific color, another hex color. She wants a specific color for the background of the facet theme. Yeah. And then she adds her final theme, which is called dumbbell theme, which she specified earlier.
All right, let's just do a quick look at that, quick logic check. There you go. So the strip background is basically the header of the strips here, and she set it to be green. The hex colors are, sorry, it doesn't appear super nice on here, but we know from her plot that it ends up looking pretty nice. So we're just really zoomed in, so you can read our code. Cool. All right. So then she goes on to create her second plot here, where she does a very similar subsetting. She also could have done filter, but this time, here, let me get rid of this since we recreated top countries. So she's keeping all the countries, the same countries, keeping the same level 1, but this time she's keeping only conventional energy. So key eyes will have seen that first plot there was all green energy types. What could be considered green energy types. This time it's only conventional thermal is what she's keeping in this one. Same sort of setup for the plots, where she's doing the X from 2016, XN 2018, grouping by country. The Y-axis is your country. I think these are the exact same settings that she had for dumbbell before. So coloring the X and XN dots, setting the stick between the two, setting the size. But then she also adds these things here. And what she's doing there is she's actually creating her own legend. It took me a sec for me to realize this, but she's adding a point with the color of the X, which I believe is 2016, and annotating it with the label 2016. And then she's also creating another point, this time with X end, and labeling it with the annotation of 2018. So now she's got within her right hand, or with P2, 2 dots with 2 annotations that are showing what the colors are and what the years are supposed to be. So I didn't immediately recognize this. Once I saw it, I was like, oh wow, that's really clever. I like what she did there.
Clever. Yeah, really good trick there. And annotate is a super useful function in ggplot too, because you can basically pick an X and a Y location and say whatever the heck you want.
Yep. Then she scales continuous with the commas. facet wrap. This is just to maintain consistency because we only have one facet at this point. But then it's to make the two plots look similar. Remove your X and Y labels, and then setting her theme. And this time she's setting it to a different hex color, so it's not going to be green this time. It'll be a different color. And then applying the same theme that she did in the last one, so it's consistent. All right, so now we've got a P2. Boom, there we go. This is what it looks like. So
you can see a makeshift legend right there on the right side, which is super cool idea.
Yeah, that's pretty clever. I might steal that in the future.
I'm gonna totally steal that one. That's a great one.
All right, so now she's putting the plots together, and she does this using the patchwork package. So P1 plus P2. So what this tells patchwork is put the two plots side by side. All right, if she'd done a division, it would have been one on top of the other, and that wouldn't have been any different really than if she'd left conventional thermal in the original facet. So this is putting them side by side so you can view them. And then she adds plot annotation. So this is where she's defining her title of the plot. So top 5 largest European energy producers. Then the subtitle, so the change in amount of energy that is produced between 2016 and 2018. And then adds, as always, and is very important, the caption. So she created this. Data's from Eurostat. Hashtag Tidy Tuesday. So let's execute that.
Run it.
And here, let's see if we can zoom out and make that look a little bit prettier. Okay, that's a little bit better. Her plot ended up looking really nice. But here you see on the left side the quote green energies over here. Nuclear, hydro, wind, solar, geothermal. And the top 5 countries, so UK, Turkey, Italy, Germany, and France. And you can see the difference in production. Wow, France really relies on nuclear energy. But then, like, you can see some and very very little conventional thermal, and has actually decreased its dependency on it. It looks like Turkey. Looks like Turkey might have increased its dependency. I think they're the only ones that increased their dependencies on conventional thermal. But yeah, great plot, great way to see kind of visually the difference between the two 2 years there, 2016 and 2018, and all the energy that's going on with that. So thank you very much, Kelly.
Yeah, it's awesome.
Really cool plot. Love what you did. Really love that legend. I don't know why. It's just blowing my mind.
I like that a lot. Yeah, that's cool.
All right. So now we're going to take the same idea of using dumbbell plots and apply it to a new data set, as we do.
Yay.
So Patrick, do you maybe want to take us through this one?
Yeah, so we're going to use some basketball data from Basketball Reference that we're going to scrape. So we're working in Markdown here, and our first thing, as always, is we load our packages and set our theme. And here I use the classic theme. We're going to use some Basketball Reference data, so we're just going to grab the URL, which is going to be the NBA player totals for the 2019 season.
Mm-hmm. Let's scrape that.
Yep.
Using rvest.
Yep, we're going to use rvest here to find the table that we want. We want to pluck the first table from that URL, and then because the folks at Basketball Reference, basically every 10 people, they add in new column headers. We're just going to get rid of those. So anytime there's a rank where the name is or where the rank is, we just ditch that and plop it out so that we have a nice data set to work with. Cool. So we can take a look at the head of the data set, the first few rows. And we can also, which is going to be really important when you're pulling these sports reference data sets, look at the data types, and you can see they all come in as characters from their data. There's probably a better way to do this, actually, because they do have a little clickable button where you can get the data as a CSV. So I'm sure you could scrape it off of that little back end as a CSV. Mm-hmm. But we didn't do that, so we'll do something different to change the columns that we need to numeric. We'll go through that one?
Sure. All right. So we looked at the data set, and this may not be the most efficient way to do it, but we looked and figured out, all right, so the columns that we know should actually be numeric, but are as class character at this point are column 1, column 4, and then all the columns between 6 and 30. So what we did is we took NBA and we piped it into a mutate, which allows us to change the type or manipulate our data, right, by column. And what we did here is we used the new functionality at a deployer called across. And so what we're doing is saying, okay, across all of these columns, all right, convert them into numeric. So so first we're going to actually expressly convert them into a character, because if you're trying to call as numeric on a factor, it'll return the factor level, which is not what we want. But if we convert a factor into a character and then into a numeric, it'll always give us the right value. There's some historical reasons behind that, but let's not really get into that. So this will convert all the columns 1, 4, 6 through 30 into numerics, and we're going to assign it to NBA clean.
Check our work.
Boom, there we go. All these are doubles. I wonder if there'd be a way to maybe use readr, because it has some parsing features in there. We can look at that in the future.
Yeah, maybe.
That was just an idea that I just had. So cool. All right, so then we jump into getting out the columns of interest, because we actually want to plot something out of this. So we take this now clean data set that has the numeric columns in there. We subset to only keep 5 columns. We keep player, their position, the number of games that they've played, the field goals
attempted,
and then the assists that they have per total.
That's on a season level. Yeah.
All right. Now we've subset, or we use select to select the columns that we care about. Now we're mutating. We're going to create some new columns that we care about. So shots per game and assists per game. And so this is a fairly straightforward metric because we have it across the season. So we divide the field
goal attempts.
Field goal. I can talk eventually. It's been a long week. Divide that by total games they played, and then assists per game. So divide assists by total games, and then we're also going to try to subset our data to keep a smaller number of players there, and say, oh, we're only going to keep players that played more than 40 games. And subset there, and then there's a possibility that a player could have played for multiple teams, multiple positions. And so what we were doing here is we're going to go, okay, now group by all the players, so group by player name. And let's go through and make it so we only have one row per player, right? Because that's what we really care about here. So we'll create a new column called positions, which is all the positions they could have played the entire season. So we take the important thing to do when you're thinking in a group, when you're doing a group by or mutate and whatnot, is think of them as vectors that represent that column, right? Because that's how they're going to behave in the functions or anything you're doing to manipulate them. So I'm calling unique on the column POS, which is the positions that they play. So we'll get for each player the unique number of positions, unique positions they played. And then I'm going to use a paste with a collapse. So when you pass a vector into paste with a collapse, it's going to produce a single string where each different entry in vector, or in that vector, is going to be separated by whatever character value you have in collapse. So in this case, it's a slash. So it'll list each position that they played separated by a slash. But we still want to keep what was their position, right? And so what we're going to do here is we're going to still treat POS as if it's a vector, but we want to know what was their most commonly played position. And so what this is going to do, which max returns the index for which the maximum value is. And so we are going to figure out which position did they play the most games at, and then let's only keep that as the POS. So that's what's going on in this row here. And then for any...
Little base R right there.
Oh yes, I love my base R. And then for any other column that is numeric, we want to sum across those to keep them so we can get a total summation for the player's numeric values.
Boom.
Boom. So let's run that. So now we've got a cleaned up data set where each row is a single player, and we have all of their games, field goal attempts, assists summed up across that.
So maybe filter out like LeBron James so we can see the positions collapsed because he would have played um, multiple positions. Yeah. Oh, he didn't. Interesting.
No. So what we could do here is do a grepl. So we're going to grep for us. So try to find slashes in
Yeah, that's
position. What did I do wrong here?
It's positions, S at the end of it.
Yeah. There we go. So like here. Jimmy Butler played
Shooting small forward
shooting guard.
/ small forward.
So there were So he was classified across multiple
Yeah, that makes total sense.
positions.
There you go.
Yeah, I guess there were only 5 players that were listed multiple times, and that happens.
Oh, that's
Well,
weird.
I mean, that's not to say that. So this is only cases where they had unique positions. So a player could have played at multiple, like, multiple teams, and this wouldn't show that
Yeah,
still.
yeah. Cool. All right, that's nice.
Yep. All right. Go for it.
All right, we'll check out our dumbbell plot here. So we've got our NBA main data. That's what we just looked at. And we're just going to plot a few guys. So we could have done this as like a Shiny app or something like that. Feel free to play with that. We've done those in previous episodes. We're going to arrange descending based on games. So the top guys will be at the top playing guys, that is. And we're going to get the top 20. So we just want the top 20 of these. First thing is a little bit of data prep here before we get into the GG plot. So we're taking the player column that we have, and we're creating a little something new here where we're now pasting in the positions that they played. And so this will just kind of feed a little more context into the plot besides the player's name. It'll give you information about maybe where that player played, which might be able to explain some of the things we're about to see. In the GG plot here, we set our x-axis or x start to assists per game, and we put our x end at shots per game. And so that's why I call it the ball hog plot, is because guys who shoot a whole bunch more than they give the ball around or dish the ball around are ball hogs. So we're looking for the guys that are the ball hogs. And then our y-axis, we're going to reorder by player and shots per game. So we want the main guys that shoot the ball and the ball hogs, right? We're going to use our Geom dumbbell. So the color of the stick is going to be black, and we set its size to 1.2. And then some information about the X's. So the X end and the X start are going to be both 5. And I'm going to use blue for the start and red for the end. Labels, we've got a little title here, which we could have called the Ball Hog Report. It's 2019 shots per game versus assists per game, though. Our subtitle kind of gives some information. I really should have pulled that awesome example from Kelly and made my own legend. That would have been really cool, but I didn't.
We just didn't think about that.
Shame on me. So I had to put it in the subtitle, and it's not as cool. My plot fails. The x-axis obviously gives our variables, and there's no need for a y-axis because everyone can clearly see that it's names, so we don't want the clutter. And then here I define the theme. So we're going to have our axis text, basically just saying on the X and Y axis, I want them to be a certain size. I want them to be bolded, and I want them to be black so they really pop out. The plot title, same thing. I want a black coloring of the plot title, and I want it to be big, 20. I don't use HJust so that it's going to be starting all the way over at the left when you're looking at the plot. Our plot subtitle is the same, just a little bit smaller than the plot title. And then I'm going to set our background and our plot background. I'm going to use light gray so they stand out. The data stands out a little bit more. And then the panel grid major and grid major X. Now, this is interesting here because I removed the all of the panel grids because I use Theme Classic, I'm only going to put back in the X major grid, and I want those colors to be white since they're going to be sitting atop of that gray line. So these are going to be vertical going bars. So we'll go ahead and run that, and we'll take a look at our dumbbell plots.
Just a sec. Helps if I run this from the top, and there we go. So let's zoom in on that.
Ball hog is Jimmy Butler. And James Harden, who's like a well-known ball hog.
Yeah, there's a big.
Gasol was super interesting. I think, is he the only center? Yeah. So there's two centers on here, but mainly it looks like it's a concentration of point guards. So let's see who else. Sure, Kyrie Irving, like massive ball hog. Damian Lillard, like controls the game. LeBron James controls the game. It's pretty much all the guys that you would expect. And then once we get down towards the bottom, we start to see like Rajon Rondo, who shoots, but he also will dish the ball out and pass it around. Tim Frazier, his actually points are directly on top, so he's pretty much
down the.
He shoots one and he gives one.
Yeah, he's a fair player.
Yeah, he's a fair player.
Well, in this context, I mean, the number of times he gives it away versus keeping it.
Correct. In the 2019 season.
Yeah.
And you can see how it was super handy to paste the positions in there. It gives it kind of a nice little context and adds information. And then you can see with the Theme Classic, all the grid lines are gone, and then I just set the X major grid lines in there for us so that we could just have a little bit clearer idea of where the points are without being cluttered with a full grid, which, especially if you change the background of the plot color, sometimes those grids are like really noisy because they're just there sticking out. And so I just use Theme Classic. I get rid of them all together, and then I feed back in exactly what I want.
Yeah. Well, I think that's what we got this week. Dumbbell plots. I mean, this was a fun little demo of how to do it. But Kelly's plot was also great. We also learned something on making our little pseudo legends there. So this was a lot of fun this week. I think we're gonna call it. So once again, thank you for joining us. My name's Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And my name's Patrick Ward, and you can find me on Twitter at OSPPatrick. You can reach the both of us at tidy.explained@gmail or at tidy_explained on Twitter. Or you could, if you're watching the screencast, you can leave a message at the bottom. We're happy to hear the feedback, questions, comments.
Yes.
So reach out.
Will. Yes, we did read the ones from this past week. We will definitely be getting to NA imputation, and then probably getting around, try to find some more good examples about writing functions and loops and that fun stuff.
Yeah. Ooh, NA imputation is a good one. Yeah.
So we'll probably be able to cover it all in one. So.
Yeah, maybe. Yeah, we'll see how messy the data is that Thomas Mock puts out next week.
Yeah, we'll see. But all right, thank you. Keep on exploring your world.